Hello, quick video on uncertainties. There's a couple of different ways that we can write uncertainties, and uncertainties, as it sounds like, it's how sure you are about an answer. Okay, so if I used a ruler to measure a distance, to measure the length of this line perhaps, what I could do is I could measure it to the nearest millimetre. Now what that means is I don't know it for sure, because I don't know whether, say I've measured it and my ruler says that this line is 8.1 centimetres, so 81 millimetres. That's all very well, but I don't know whether it's exactly 8.1. It might be 8.11. It might be 8.12. In fact, if I've measured it 8.1, well, that's anything really up to 8.14999 reoccurring. That's going to be, I'm going to have measured that as 8.1. In fact, if it was just less than 8.1, I'd have the same. So if I had anything from 8.05 above, I would measure it as 8.1. So can you see, my measurement of 8.1, it's got a range of results that it could be. Now, just a little bit confusingly, I might not have got 0 in exactly the right place either. So what actually happens is, can you see here, I've got half a millimetre either way that I could be out on my reading 8.1. I've also got half a millimetre I could be out in measuring 0. So what I'd actually have to give this measurement to as is 8.1 centimetre plus or minus 0.1 centimetre. This is called an absolute uncertainty because it tells us the size of the uncertainty in the same unit as it tells you the measurement. So 8.1 centimetres plus or minus 0.1 centimetres, that's my absolute uncertainty. Now, an easy way to be able to work out what the uncertainty is, if it's a single measurement, what you do is you just take the smallest increment that that whatever you're using to measure it can measure. So, for instance, here, my ruler could measure to the nearest millimetre. Half a millimetre out at the top, half a millimetre out at the bottom. Total uncertainty is 1 millimetre. Okay, so your absolute uncertainty for most of the time, you can take it to the smallest increment that something could measure. So say I used a micrometer and I found out that I've measured something and it was 22.3 millimetres. Okay, or 22.30 actually, you can measure it to that significance. Okay, 22.30 millimetres. Because I can measure to 0.01 millimetres with a micrometer, I could say 22.30 millimetres plus or minus 0.01 millimetre. Okay, so if I'm just taking one measurement and I'm sure my measurement is accurate in that my measurement is the right measurement, then my uncertainty is just the smallest thing that it can measure. Sometimes I might have a range of measurements though. Say I was doing a calculation and I was doing an experiment where I had to measure a particular length that something had gone after a particular time or something like that. If I had a number of lengths, so say I had 0.417 metres, 0.432 metres, 0.431 metres and 0.421 metres. Well, what I'd have to do to find what I was going to quote that result to is, the first thing is I'd have to find the mean, the average. So I'd do that like we normally find the mean, the average. I will add them together. So 0.417 plus 0.431 plus 0.432 plus 0.421. Add them together, divide by 4, because there's 4 of them, I get an answer of 0.42525. Now, as I said in the last video, what I would probably do with that is I would round that to make sure it's the same number of significant figures. So that would be 0.425 metres. Now, it can't be 0.425 plus or minus 0.001 because some of these measurements are outside of that. So what you do in this case, if we've got a range of measurements, what we use, and mathematically it doesn't always work, but we can think about that, we use half of the range. So here, my biggest number is this one, isn't it? 0.432. My smallest number is this one, 0.417. So if I do 0.432, take away 0.417, I've got a range of 0.015. So my range is 0.015. So that's from the smallest result all the way up to the biggest result. Smallest result there, biggest result there. My mean, hopefully, would be somewhere around the middle, okay? So what I would do is I would quote, because I've got this whole range here, my mean's halfway through the middle. What that means is I look for my uncertainty, my absolute uncertainty would be half of the range. So here my absolute uncertainty would be 0.015. I divide it by 2 and I get my absolute uncertainty to be 0.0075. Now, if I'm looking at how I'm going to write that, I'm writing this to the nearest 0.001. So I will round this to the nearest 0.00. That's the digit I'm interested in. So that's a 5. I'll round that up. That's to 0.008 metres. So by far the most common thing you'll have to do is use the smallest increment on whatever it is that we're measuring. However, be aware that we've also got to use the range. Now, sometimes we don't want to give our uncertainties as absolute uncertainties. Sometimes we want to give them as percentage uncertainties. To find our percentage uncertainty, what we do is we do our absolute uncertainty and then we divide it by our measurement, and then to put it into percentage, we multiply by 100. Let me show you using this data here. If I wanted to write this as a percentage uncertainty, I'd write it 8.1 centimetres. Well, that's my measurement still. If I look for the percentage, I would do 0.1 divided by 8.1, multiply my answer by 100. So if I put that into my calculator, I get an answer of 1.2%. So I've got 8.1 centimetres plus or minus 1.2%. Okay, it's just over, but if I know that to two significant figures, that being to two significant figures will be absolutely fine. The next measurement, it's a very small uncertainty. Just move the camera this way so you can see 22.30 plus or minus 0.01. So if I put that into my calculator, I've got 0.01. Dividing by 22.30, multiplying it by 100, very small percentage, I've got this to be plus or minus 0.045%. Okay, so I would probably write that as 22.30 millimetres. We'd have to think about how many significant figures, but it's going to be very tiny amounts, so I'll just put it into for 0.045% because I think any other significant figures, because it's a small number, wouldn't particularly be useful. Right, my last one down here, I've got my answer here was 0.425 plus or minus 0.008. So here, to put it into percentage uncertainty, I'd write it as 0.425 metres. I've got to do 0.008 divided by 0.425, multiply it by 100 to put it into percentage, and I've got plus or minus 1.88%. Okay, so sometimes it is useful for knowing it as a percentage rather than absolute. I'll show you quickly why that would be something to think about. Say we were using an ordinary ruler that measured to the nearest millimetre, and we're measuring a distance of 20 centimetres. We'd write that as 20.0 centimetres plus or minus 0.1 centimetres. We'd probably put it in metres really, because we like using metres better. If I was putting that into percentage uncertainty, well, we've got 0.1 divided by 20.0 times 100. We've got a percentage uncertainty there of 0.5%. Okay. Now let's say I was using the same metre ruler to measure something that was exactly 2 centimetres long. 2 centimetres long, it would still be plus or minus 0.1 centimetre. This time, if I look at the uncertainty, I'll do the similar calculation and you'll see that it comes up to be 2 centimetres plus or minus 5%. So it's more significant, this uncertainty, the smaller the distance is that we're measuring with this ruler. Well, let's see, you can probably see already what happens if we were trying to measure something that was 0.2 centimetres long. Now, 0.2 centimetres long with a normal ruler, we'd have 0.1 centimetre as our uncertainty. So what that would become if I divided 0.1 by 0.2 multiplied by 100, you can see that's 50% uncertain. So all of them have got the same uncertainty, absolute uncertainty, but the percentage uncertainty depends on what we're measuring it with. It's fine for this sort of distance here. It's okay for this sort of distance here. But if we're measuring something this small, well, then we probably don't want to use our ruler. We probably want to get our vernier calipers or our micrometer out to measure that.